So we have been solving quadratic equations by the method of factoring, applying the zero product property, factoring one side of it, and setting each one of those factors equal to 0. So whenever you go to solve a quadratic function, you are finding the x-intercepts that make the function equal to 0. So I want you to be able to associate these things with solving quadratic. So solving quadratic, what it means is, first of all, it's the same thing as, here's a word for you, finding the roots of the quadratic equation. We will see why specifically that is called the roots of the quadratic equation in the next lesson. It has something to do with square roots. Okay, it's the same thing as finding the roots of the quadratic equation. It's the same thing as finding the x values as the x-intercepts, because you're setting y equal to 0, and whenever you set y equal to 0, this is on the x-axis. And then finally, it's the same thing as finding the zeros of the quadratic function. A zero of a function is where the function is equal to 0. Like f of x, where f of x is equal to 0, that's the same thing as y. So associate all of these things with solving quadratics. Finding the roots, finding the x-intercepts, and finding the zeros of the quadratic function. Okay? So let's do some of those right here. No, not yet. Another question. There can be, remember from that sketchpad thing that we saw, since we're talking about finding the zeros or finding the x-intercepts, how many solutions can there be? Well, with this little picture we can see that it's possible that we have no solutions. This is where the parabola doesn't touch the x-axis at all. We're going to see in another lesson that means that it doesn't mean that you don't have any you do not have any solutions. It just means that the solutions are going to be imaginary. Anyway, it's possible that you have two solutions where it just crosses the two x-intercepts, crosses the x-axis at two places, like x equals 3 and x equals 5, something like that. And then finally, one solution. So I want you to think about for a second, what's going to be true if you just have one solution, right, where that vertex of the parabola just touches the x-axis? Well, if you have just one solution, doesn't it mean that both of the factors, if you go to factor it, are exactly the same? Right? So that you would get x equals -3 and x equals -3. In that case, that means that you have a perfect square trinomial, right? Because it would be x minus 3 squared. Okay, well, let's look at a few of these. So find the roots of each of these equations. Finding the roots means solve it. Solve the quadratic equation when it's equal to 0. So, remember, what I'm trying to do by this method is just factor one side of this thing. So since I only have two terms here, it's a binomial. First step is always GCF. Well, look, they both have an x in common. So I'm going to factor this as x times x plus 2 equals 0. Okay? So set each one of these factors equal to 0. So the first one is x equals 0. And the other one, x plus 2 equals 0, so x is -2. So there's the second one. Okay, so it is a parabola. If this was a parabola, it would touch the x-axis twice. Okay, and how about a red one? So x squared minus 12x plus 36. Ooh, wait, 36? That's a perfect square. So let me check to see if this is a perfect square trinomial. So I take the 12 and I take half of it. So I take half of that and I get 6, and I square that, I get 36. So yeah, it's a perfect square trinomial, and it factors as x minus 6 squared. Well, it's the same thing as x minus 6 times x minus 6, right? So whenever you set it equal to 0, each one of those factors equal to 0, you're just going to get x equals 6. No matter what, x equals 6. For the other one, it would be x equals 6. This means that it touches the x-axis at just one place. Like if you're going to draw the graph, it would just be like this, where the vertex would be at 6. Okay? Now then, no, that's not right. Let's change color one more time. Okay, how about x squared plus 1 equals 0? I'm going to try to factor that thing. X squared plus, alright, it's binomial. When it's a binomial and it's squared, let's see, there's no GCF. Oh, this is the sum of two squares. Oh, but wait, the sum of two squares, that's prime. You can't factor this. It's prime. Now let me show you something here. Another way that we're going to learn to solve these things is just isolating, if there's no linear term, is to isolate the square terms equals -1 and just subtract the 1 over and then take the square root. X is equal to the square root of -1. Square root of a -1, this means that it is imaginary. Imaginary. And that will be a lesson in this unit at some point. And what this will mean is that whenever you go to graph your parabola, like so, it would just not touch the x-axis at all. Okay, last one. This one calls for some green. So let's try to factor this one here. Product is supposed to be equal to 4, and the sum is supposed to be equal to 2. So let's see. We've got 1 and 4. That's not going to give us 2. We've got 2 and 2. That's also not going to give us 2. Well, this means that it is not factorable. And we do not have enough tools yet in order to solve it. Now, just because it's not factorable doesn't mean that you're not going to have a solution. It does not mean that they're going to be imaginary like it was in number 3. It's possible that they are irrational. They still touch the x-axis, but at weird spots. So we need more information to be able to do number 4. Okay, so I want you to try, well, to explain why can you not use the zero product property to solve every quadratic equation? Why can't you solve it by setting each one of the factors equal to 0? If I go back to this, if I look at number 4, it's simply because sometimes that quadratic is not factorable. So even though this is an easy enough way to understand what you're supposed to do, it's limited in that you can't solve every single quadratic equation this way, because you can't always factor. Okay, so now here are 4 of them for you to try. Go ahead and pause the video, finding the zeros of each of the functions, which of course means where y is equal to 0. So set them equal to 0 and then do some factoring. All right, so let's look at your answers here. We'll look at each one of these problems individually. So on the first one, you set it equal to 0. I first took out the GCF here, which is the 4, and then it made the quadratic a little bit easier to factor. Notice it's the difference of two squares, so 2x plus 1 and 2x minus 1. Now, whenever you apply the zero product property, you don't apply it to 4 because 4 can't be 0, so that one doesn't make sense. You apply it to the two that are in the parentheses, the ones that have the variables in it. So I get a positive 1/2 and negative 1/2. You could write your answer, if you wanted to, as x is equal to plus or minus 1/2, right? Okay. So on the second one you set it equal to 0, and you see 9 and 4. Hey, those things are perfect squares, so you check out the middle term. So the square root of 9 is 3. The square root of 4 is 2. 3 times 2 is 6. If you double it, you get 12, so that's a perfect square trinomial. Factors as 3x plus 2 squared, which just means you have 3x plus 2, 3x plus 2. You set them both equal to 0. It's the same thing, so you might as well just only do it once. You got x equals negative 2/3, which means, of course, that this is where the vertex would touch the x-axis. It only touch one place. Okay, number 3. I did this one by guessing and checking. Open up my two set of parentheses. The first two places have to multiply up to 5, so I chose 5x and x since it's prime. The last ones have to multiply up to 3. Again, it's prime, 1 and 3. I put the 3 opposite the 5 because we're trying to get up to 16. So the outside terms 15, the inside terms 1. You add those things up, you get 16. Set them both equal to 0. You get x equals negative 1/5 and x equals negative 3. Finally, number 4, you try to factor this thing and it's just not factorable. They're supposed to multiply up to, if I use the AC method, 2 times 3 gives you 6. It's supposed to add up to the middle term of 1. And you might go, oh, well, 2 and 3. The problem is that would only work if one of them was positive and one was negative, so they could subtract. However, since these signs are all positive, everything has to stay positive, so you can't factor that one. That doesn't necessarily mean you don't have any answers. It means that you can't do it by factoring. You may have to use either the quadratic formula or whenever we learn it, this technique called completing the square. Okay, so that's it on this video. I'm going to have some more application videos or exercises in the next video. Quadratic, solving them. It'll be fun.